So two of us are in California. That's me and Michael, and the other two guys are in Taipei. So two master students. You find me annoying Gabber who asking a lot of questions on the room. So a lot of you have tried this data set. I'm pretty amazed actually. It's been a group effort really. It's always been a humbling process to see so many people point out bugs with each other's thinking. It's been a proof for me that yes, we can work together, follow the great paper to the letter. It's beautifully spec'd out, and to work together to build the anti-fragile future that Gav has predicted we could do. So it works. So I didn't know that this was going to happen, but this past few months, basically, somewhere between January and April, I was like, yeah, this is working, because so many of you, I don't know, at least 8 or 9 teams have been able to point out problems with our implementation or being able to resolve discrepancies between what we interpreted and what somebody else interpreted. So in these, we had basically in February and April, we had 2 kind of big pushes, and I think there will be more. Where in 6.2 we had like a whole bunch of stuff where we started with the Genesis block and some news, and we got through a lot of little issues, and after working through this, we on the next two versions later, we had a much easier time getting to convergence. And I'm like, what do you want me to? Okay, sure. Yes. Can you hear me? Okay, good. Does that help? All right. So we have. All right. Let's see if I can do this. So.
No.
Hello. All right. I can
try
always
this one.
This one.
It's
That's
over
good.
there.
Hello. All right. Yeah. So we have, I guess, 6 or 7 teams actively doing this, and we're continuing on with the latest publication, which just came out yesterday, right? So Galisi did an important change that was very useful for us to sort of clear up the state transitions data set to the 31 bytes. We had a bunch of like, we got all this metadata going around, so we just quickly cleaned up in the last few days to be consistent with his latest PR. So you should all check it out if you've all been following along with whatever we've been doing. So I think this is a really important change. We probably got more addicted to the metadata stuff than we had to, and we had a bunch of disputes with like, does he really need this or not? Gab was concerned about having this metadata in a shadow data form, so we eliminated all of that stuff and said, yeah, you can do this all. You can derive the state root with just the state keys, and you don't need any metadata. And with JIP, 2, we implemented the subscribe stuff. We realized that all the metadata things that we wanted to have, if you guys just go a little bit into further and just implement JIP2 with those subscribes, you can stick those into the what we calling state snapshots. So we now have a completely compatible with Galisi's PR45, which you guys should all check out. And we don't think we need to publish these anymore, the fallback and Safrel, because Galisi's covering it. And we're just going to keep doing what we've been doing before with these assurances, really like core VM, light in our own head, and order accumulation with these test cases. And that's kind of like what we'll continue to do in sort of whatever Galisi's format is. There's one little detail that he wanted us to get alignment on, with gas being 1 rather than 0. That required us to fuss with whatever initial refine and accumulate gas. We're now like sort of gas focused right now in a way that we didn't do before. But yeah, same sort of stuff we did before, fixing bugs. So thank you all for contributing. I hope we can continue publishing sophisticated data sets, testing out all new things. If there's fetched from 17 or whatever new things, we should just keep advancing our test data sets so that we as a community can have a robust test vector set that we can all share with each other and fuzz or do whatever we want. So we all have the anti-fragile thing that we can work towards. So this is just our first thing. You guys can try to check it out and see if you can quickly match up with what Lacey has with the SAT roll and fallback, which a lot of you have gotten to do already for the 6.2 and 6.4. Keep going, but you'll have to do that 31 byte transformation. We have, I guess, gotten a little more advanced than others on this because we have gotten through refining. I don't know, when I was a student, we had this thing called Game of Life, which was our freshman-like thing where you can test it out. So if you want to take a look at this, let's see if I can pull this off. Is this going to render? Sort of. Was an ad. Oh, crap. Do I have to skip on this? Oh, there it is.
You need to install AdBlock.
Huh? Is that working?
You need AdBlock.
AdBlock, so I'm not that clever. Sorry, yeah, I should do that. So this is our William on our team. Oh, let's see. Is this going to work? Yeah, good enough. So over here is our the same kind of stuff that you see in the assurances.txt and order accumulation. That's our thing running, and this is what a lot of people who see it as this tool recognize as the game of life. It's a very simple rule set. You basically have every element in the grid recomputed based on the number of neighbors that are lit up or not. Very simple algorithm. You can write it up in Rust in less than a day or probably an afternoon. You can get ChatGPT to write it for you. And there's like really interesting objects. This one's called a glider, and what you see here is a sped up version of Game of Life running through these work packages that are basically rendering in very similar ways to the Doom demo that Gab gives and Jan and so on. So this was our first demo from April. We were kind of happy we got to that. And just this weekend, we had the same sort of success there. Nowhere near Jan's performance. I don't know what we'll hopefully learn by tomorrow, but what you see here is also a sped up version. This is not running through work packages. This is just running PVM only, okay? So the previous demo was running through work packages, 100 steps or something at a time for Game of Life. Here, what you have is us doing just pure PVM execution where each of the frames that you see here on William's computer anyway is running at 15 seconds. So hopefully we'll learn something about how to speed that up through linear compilation maybe tomorrow, hopefully. Let's see. Let's see here. So that's kind of what we've been doing. So we have gotten to an increasingly robust tiny testnet with 2 cores. This is something which I took out of our latest tiny testnet. So here what you have is, a day and a half of data. Each line here is an hour, and we have 400 work packages per hour. You can do more than that. We haven't really pipelined the hell out of it yet, but that's a start. And we're happy to report that we can, do the usual thing in distributed systems where you kill a node, swap, make sure the other 5 guys can survive, yay, and then you can bring it back to life. And so every few minutes or every few hours, you can turn it off and see if it syncs. So great. So with that sort of automation, we're happy to. We're running like 2 to 3 days now without any issue, which requires a lot of garbage collection or state TVs or whatever. One of our guys has started to build a block explorer. Let's see if this works. I don't know if it's going to happen. Will it work here? Maybe not. Okay, yeah. Well, anyway, so we took what am I saying here? JIP2 stuff and have this live. It's not okay. So sorry. So every single time so what you see in the order accumulation data set is 2 cores with let's see what I'm saying here. 2 services running on 1 core, 1 service taking the results of the first coring these two services and accumulating them all in the same state transition. And this is something that it actually powers that 36-hour test. So that's what you have running 400 times per hour, something like this. So this is actually some version of JIV2, JIV2, and this is kind of like a good old-fashioned Etherscan style block explorer, except instead of transactions, you have work packages. It uses all those new services and all that good stuff. So that's kind of well underway. So we have something going on there. We thought, just for the hell of it, let's see if we can turn all of our Explorer stuff, stick it into the much beloved or much hated Polkadot.js. So that actually turned out to be not that bad. So let's see. Our idea about how we could proceed is to make this open source and have every one of you implementers listed out here, just like all the other parachains and relay chain, system chain over there, for us to have a nice place to have pretty much the same kind of block explorer that you see there. Let's see if we can do it. So this is like an open source type idea that we can all come together on. That would require, of course, that you, with your implementation, conform to the JIV2 stuff that has been that's sort of in progress. So we'll have to see how that works. So when you actually look at those data sets, assurances, and order accumulation, they're actually all open source. I don't see many of you guys playing with this as much as I thought. So if you guys want to, and I think we should all try to do more of this, build more services, you can go check this out. So I encourage you to all do this. Everything you see in the assurances, order accumulation, and game of life, and maybe Doom or whatever, you can actually play with yourself. Meaning you can take these and create your own, test set for, checking out fetch 1 through 17 or whatever. They're all there. If you look at the top level, there's a makefile, and if you follow if you just spend a little time getting your Rust toolchain in order, which is a little bit of a task, then every one of these services are things that you can build and you can actually run through and hopefully become a macro, a refiner of some order, right? So so that's all something I'd like to see all of us do more refining. We're more refining with active service building. In our previous life, prior to being jammers, I guess a team of 4 or 5 of us, I spent a lot of time doing indexing of the whole Polkadot ecosystem. We at Colorful Motion do the Dune and BigQuery data sets. And I wanted to, I don't know where Emmett is or who wants to talk about this, but you guys, I think it's important for us to jump into the performance of our implementation game. That's what M3 in part is all about. So I'll zip through this, but where we can put together a testnet leaderboard where we can compare all our implementations in terms of how each of our key operations, how much time they take, how much time does it take to author, which dominates with PDM execution, or refine something which also dominates. So as we get into the middle of how good is your interpreter, or how good is your recompiler, we're going to have to compare our results. And I think we are eager to talk. I'm eager to talk about JIV3 with whoever wants to talk about structured logging. That'll be a cool topic. And we can also stream all this stuff into the same tools. So I envision that as we go from our individual 6-element tiny testnets straight into the toaster, we could instrument the hell out of it. And if we do it in a simple way, we can plug in all of our events and have that show up into whatever BigQuery type data systems we want. Because we were familiar with BigQuery and are pretty good at it, we just chose this and we kind of built schemas in both of the systems that we know. And I think that could be a start for structured logging. In terms of our goals for the next 2 or 3 months, this summer mostly, as we get beyond whatever 6.6 was with fetch and max code sizes and so forth. I think it would be possible for us to publish binaries, maybe, for the guys who can compile their Jam implementations. Do it in a hopefully clean room way. Let the judge decide what we can and cannot do. We'll write up the milestones and hopefully learn how to do linear recompilation and get into the game where we have our implementations connected and wired up in a network Jam SNP way. We are going to, having gotten this far, keep going with Grandpa and Warp Sync. We have a couple of codes out there sort of collecting dust right now, so we're now ready to do it. And these are kind of our May and June challenges for ourselves. Mostly Grandpa and oriented and our interpretation of what we think can happen with core VM and core play. Hopefully that's it. Across the many teams, we think it would be really cool for us to get multi-client more or less as soon as possible, to go from just importing each other's blocks and making sure that we get the same answer and get ready for the toaster. I think we can make it a big deal for us to improve .jam chain and make it awesome. I think we definitely have enough content now as a community to pull it off relative to other players in the space who also focus on getting correctness, proving correctness of results. And we'll also look forward to having a functioning Jam implementers DAO. We were selected to be a delegate, and Kirill set up the Discord room, so it's now a different place to play and interact and get involved politically in Polkadot in ways that only maybe some of us have engaged in a large way, and I think that'll be a lot of fun. So if you haven't joined already, please consider jumping into the Discord room and interacting with all of us. Over the last 2 or 3 weeks, I've just seen so many. I've seen a lot. I've learned a lot of your ISAs just from seeing you interact with OpenGov. And I think parallel to our testnet and engineering life, we can just have fun being functioning political entities, so that we become very close to what Polkadot's future is all about, because that's what we're building. Yeah, so that's that. If you have any questions, hopefully tomorrow or the next couple of days, if you're ready to do a testnet, I am too. I guess the only guys that we got to work with on a testnet so far, Jason at Java Jam. We did a little bit of connection, but that's just the start. All we really learned was, we missed some kind of uppercase this and lowercase that. So I think we're gonna have a lot of fun over the next couple months. Trying to put it all together, hopefully in the toaster, which I guess we're all going to go check out on a bus trip in an hour or less. All right. Any questions, or you guys want to talk about anything else?
The metadata, let's say, is that what do you mean is gone? Is gone? Where is it gone? And from the metadata from your vectors, you said that it's gone?
Let's see, where do I put it now? Yeah, so you can check it out. Let's see if I won't get lucky that quickly. But what just happened? Yeah, so if you look inside, so what happened, one of the cool things that Lacey did is he said he put the Genesis block and the Genesis state all in 000000, whatever. Okay, and then but he said no metadata. Okay, so we're like, oh, what are we gonna do with that? That's so useful to do for debugging. So where is it now? Let's see if I can find one by accident. So at the very end of all of our JSON stuff, let's see if I get lucky. There is a new field. Damn. Okay, let's see if I click the other one. There's a new field called state updates. And so all it is really
So all the deltas are there. Or?
all the deltas.
Yeah, exactly.
So instead of saying, I'm going to keep all the metadata for every single state storage and info and create, I'm just going to have the deltas, and you can see that it's all there.
Exactly. And the state transitions still have the metadata to the state?
No.
Because I use those.
Too bad.
Yeah, too bad.
So I think it's important for us to not go divergent
Yeah,
on the key things. So
Yeah,
I think
exactly.
Lucy's here. No. Okay. All right. So I think Lisa's plan is that he'll just fuzz. That'll be the primary thing, is the state transition stuff. But I wanted to have all of us to be able to have intelligent conversations on it and debug shit together. So that's cool. Hopefully you're not too disappointed.
I'm a bit disappointed. That
Too bad.
That doesn't matter.
Yeah. Anyway, so I think Jason and a couple of guys are like, "Wow, man, you can't do this." But no, you can do it with 32 and 31 bytes, and you don't need the original stuff. So cure yourself of that addiction. Anyone else? Anything cool like that? Yes? Okay, so hopefully we'll do some cool stuff tomorrow. We're here for 3 days at least. And if we can, hopefully we can come by on May 8th and we can hack together or whatever we didn't get to do tomorrow. So, yeah. Thank you all.
Thank you.